Apex dropping bombs.
Hello and welcome to Defend the Rhino. This is a special Data Skills Live being run as part of the Ada Scotland Festival. I'm Daniel Devine, I'm a computer scientist and engineer, and I love anything to do with data and computers. You're about to get hands-on and learn data science skills in this interactive activity. Data science is the set of skills that people need to ask questions, collect, analyse, interpret and communicate all about data. We need more people to know how computers use data, and we need more people to know how to use data to help other humans make better decisions. With me today is Park Ranger Craig.
Thanks, Daniel. So hello, I'm Craig and I love all things digital, but I'm also interested in ways that we can use technology to help people, and in today's case, animals as well. We are coming to you today from our National Park Operations Centre, which is near South Africa, and we have a huge amount of data to deal with today. Now, what is data? So data is information. It's things that we know. So it's things like facts or figures, measurements, things that we've counted. And data science is about collecting that data, understanding it, and using it to make decisions. And today we're joined by a network of data scientists. That's you. And thank you for joining us from all across Scotland today and further afield. So we know some of the groups who are taking part today, Daniel. So let's give a shout out to some of these groups. If we shout it out in your class, you can respond, you can shout out, see if we can hear you, and make sure me and Daniel can hear you shouting out loud from our operations centre. So first of all, let's say hello to Mr. Henderson's S3 class at our Growth Academy. Hello to you, thanks for taking part. And Ms. Pedden's class as well, thanks for taking part today.
Hello to Miss Campbell's class in Linlithgow, and I can see that Mrs. Hogg's class, you're joining us as well. Welcome.
We've also got some international participants taking part today. Hello to Claire joining us from Ireland, and we'll be able to give a few more shout outs later on in the activity today. So Daniel, what is it we're doing today?
The charity Save the Rhino says that South Africa has been the country hardest hit by illegal poaching. And by 2017, 1,000 rhinos were being killed every year by poachers. Now we've got a park ranger on the ground, Bokomozo, and he's received a message that poachers have been seen nearby, and we think that they're preparing to attack a crash of rhinos. We think they're going to attack soon, so you're going to need to work together. Today, you're going to be our data science team and help us stop this gang of rhino poachers. You're going to collect data from security cameras located across the national park. Then you'll analyse that data to look for patterns and suspicious activity. And finally, you'll visualise that data and figure out where the poachers are so we can stop them in time.
So, are you ready to get started? Let's watch a video to learn more about our mission today.
Let's get started. So make sure you're on cyberskillslive.com and then click on Defend the Rhino and start the live lesson. So you just want to follow the instructions on screen and answer the questions to get started.
So once you've gone to the website and signed in below, we'll be tracking your progress and giving you hints and help along the way. So don't worry if you fall behind or get stuck, or even if you've never done anything like this before, we'll be here to help you catch up. So when you sign in, go to the website and then you're going to click on Start the Live Lesson, and then it's going to get you to put your first name in, and then it's going to get you to choose your school or your group from the drop-down list. So you'll do that to sign in. And Daniel, we've got lots of digital park rangers joining us today. And thank you for joining us and taking part. And don't worry if you've just joined now. I think we've just been told there's a few more people starting to sign in, Daniel. We're only just getting started.
Yeah, absolutely.
If you're an adult, you can tweet us today at data_schools and at Ada Scott, and you can use the hashtag DataSkillsLive. We love to see your pictures of groups taking part and nice messages as you start to help us defend the rhinos.
So we've already started to collect some data about you, and you've been providing some data. So we can see your park ranger name and we can also see your avatar. So let's take a look and see who's joining us. So I can see that David from Ross Hall Academy is here. Thank you for joining us. We've got someone I and M also at Ross Hall. Edvin's at Arbroath, you just created your avatar. So on this screen here, we can see all of your progress and we can give you shout outs as we go through the activity. And at the start, we also asked you, what's your favourite wild animal? So we collected that data by asking you the question, and now we can analyse the results to try and understand which animal is most popular with all of you who are playing so far. So like Craig says...
Exactly, Daniel, this is a data science live lesson. We can't go for the first 5 minutes without having at least one chart.
We need a chart. So
where is it?
It's over there. So this is what you've said so far. I can see a lot of you are still joining and you've not been asked this question yet. So as you answer it, the pie chart's going to update live in real time. But Craig, what do you think has kind of been the most popular here? At least we've got a bit of a tie between elephants and giraffes.
Elephants and giraffes both doing very well at the moment. And as more people come in, you know, I'm surprised that the rhino is so low, considering those are the ones that we're trying to help today. But, you know, as more people start to play it, I'm sure that will change.
Yeah.
So this pie chart is an example of data visualization. So rather than us just trying to like read a list of exactly what animal is your favorite, we've got you to vote for it and we're visualizing the result. It's much easier to look at a chart like this and get an idea of the spread of different animals that have been chosen than it would be if I just had a list and I had to try and like count to myself or work it out that way.
Yeah, and I can see that there's a few of you logging in still as well. So, you know, if you have just joined us, go to cyberskillslive.com and then click on Start the Live Lesson, and you'll be kept up to speed. We're only just getting started. Oh, Craig, I can see that Bokamoza, the park ranger, wants to speak to us. Are you happy for me to put him through?
Yep, put him on.
Put him on.
30 minutes until the poachers attack. Keep going.
Oh no, we better get started, Daniel. 30 minutes.
Yeah, 30 minutes to go. So the first thing you need to do is collect the data. We've got security posts which are all across the park, and these will have a bunch of sensors that are collecting data. So we need you to collect the data from these posts.
So to do that, follow the instructions on the screen and collect that security data. So we'll let people work through this just now, Daniel, but probably why don't we just introduce that little our little dashboard that we're using today as well?
Yeah, so we have even more data that we can bring up to sort of see how we're getting on. So we've got a few different numbers. We'll come back to these two underneath me in just a bit, but Craig, could you maybe explain the ones underneath your video?
The Rhino safety level is giving a sort of an indication of, a prediction about how safe we think the rhinos are at the moment. So we're analysing lots of information, lots of intelligence, and at the moment we're only about 18%. So to me that suggests, that's quite a low level of confidence in the safeties of the rhinos, and that's what Bokamozo's saying as well. Poachers are approaching. What can we do to protect them? And I can see that over 30 of you are already playing just now as well.
Great. So just while we're doing these first steps, we're talking about sort of these security posts which are in the park. What are these, Craig?
Yeah, so these posts are all around this national park, and the national park is massive as well, and they have all types of different sensors in them. So they can do things like collect data about the weather, light levels. They also have motion sensors as well. But the key thing that they've got that we're going to be using today is a camera sensor, so they can take pictures. Now, we need you to collect those pictures and analyse them to find the poachers. So what you're doing now is you're downloading a copy of that data so we can start to analyse all of those pictures. So follow the instructions on your screen and keep answering those questions.
Now, there's another question that you've been asked, and it's all about sort of a piece of technology that park rangers could use to keep an eye on the animals. So I think, Craig, we could take a look and see what some of you have been
Sounds good.
Some of you have been saying. So I can see that Sarah has said you could use satellites to keep track of the rhinos. So yeah, there are satellites which are accurate enough that they could maybe recognize groups of rhinos. Yeah, definitely. That's a piece of technology.
Certainly what that would allow you to do is you could tell that a big group of rhinos had moved somewhere else. So you might not be able to work out, and you might not see a person, but you might see, wow, all the animals are moving away from a certain place. That might mean there's some sort of disruption there.
Bethany's saying binoculars. So yeah, I suppose if you had people on the ground, you had people nearby, maybe in sort of like in jeeps, you could use binoculars and keep an eye on them from relatively close. I suppose binoculars are technically a piece of technology, even if they're not electronic.
Not digital technology necessarily.
Kelly, you're saying cameras. That's one of the pieces of technology that these posts have. This is interesting, Craig. Logan and Kendon have both said drones.
Drones, yeah, with cameras on them as well. Now, what's quite interesting about that is that you would think drones would be a good way of looking over like big areas as well, and that's true. But Daniel, some of the problems might be with drones are, it would be fine if you were just trying to investigate like a large field or a big area like that. But these parks are massive, and I don't know how good the sort of, I won't say battery life is in a drone at the moment, Daniel. Like, I don't think you would be able to fly from one end of the park to the other as well using a drone.
Yeah, I think that's really the problem. And also these parks can be quite dusty, and it's quite a difficult environment for a lot of technology. But yeah, I suppose drones might be an option in future if the battery tech gets better or things like that. Yeah, definitely. It's a good suggestion.
I love all these answers that are coming in, Daniel, because we've ranged from like satellite imagery, advanced drones, right through to binoculars. So,
Yes.
you've got something at every level here as well. So what are people doing at the moment, Daniel?
Yeah, let's take a look. So it looks like a few of you are looking at some photos to see if they look suspicious, like maybe whether there's a human in the photo or not. So, Craig, why are we doing that? Like, why are we collecting these images? What's the what's the point?
So once we've collected all the images from the cameras, you'll need to analyse it to see if you can find any human poachers in the images. So basically what you're doing is you're looking for an image with a human being in it, because that might be a poacher who's about to attack the rhinos. Now, the problem is, I can see you all working through it just now. We have loads of images to sort through. There's nearly 16 million, Daniel. So that's because, these high quality images, they're on the cameras right across the park. That's a long time to be working through these images.
Yeah, that's a lot of images, Craig. And I suppose as well, the number of images is constantly going up because we've got all of these posts and they're all constantly taking photos as well. I can see that Anne's just joined us. Thanks for joining. You're at Dunoon Grammar School. Logan, you've been answering some questions. You're at Arbroath.
Don't worry if you've just joined just now. I see there's a few more groups just joining us at this point. Don't worry, we'll keep everyone up to date as well. So Daniel, I think we'll give people another maybe another minute or two to work through these images, to scroll through them and try and spot humans.
Yeah, I agree. I think that'd be a good idea. Maybe while the people have just gotten started or kind of getting up to speed, we could take a look at our animal preferences pie chart and see if the results have changed at all. So we have the giraffe has taken the lead. So it seems the giraffe is the most popular animal with all of you. We can say that conclusively. Elephant is still in second place, and then we've got a tie between hippos and rhinos in last place.
Although this is very interesting data, Daniel, I feel this is distracting us from our main activity of looking all through those images. But I can tell from what's happening on the dashboard here, look, we're not getting through it at a quick enough rate here. But it's not our fault. Like, there's 16 million images. People are scrolling through it right now. They're looking at all those images. It's going at a rate. It's going to take years to go through all these photos. Daniel, we've only got half an hour.
I know, we've got a lot to go through. So once you get to the step, keep scrolling through those images, keep looking to see if you can spot people, because yeah, we've got a lot to do, and these cameras are taking new photos every second, and we need to check them too.
Ailey from Mintlaw Academy's just downloaded the images. We've got 60 million to get through, so we need to get people to let's give people, Daniel. I think there's some people still getting through this activity, so I think we'll give everyone maybe one more minute to work on this.
Yeah, I think 1 more minute would be a good idea. Let's take a look and see what other technologies people have been suggesting.
You do that. I'm just making sure that people have got their names approved and signed in.
Super. So yeah, a lot of you are saying cameras. Daisy, Oliver, Michael, Jack, Anne. You've said binoculars as well. Abby saying cameras, Ailey saying security cameras, Orla saying trackers. Yeah, so quite often in these national parks, especially where it's animals and they're from the more endangered species, quite often one or two in each group, in each pack, will have a tracker attached to them, and that means that the park rangers can see where those groups are at any point on the map. So sometimes they use GPS, sometimes they use long wave radio, and you see those things that look like a TV aerial that you walk around and they beep when you get nearby. Yeah, absolutely, that is another piece of technology that does get used.
The trackers are good for keeping track of where the animals actually are, but the people who are the park rangers have found that unfortunately they don't deter poachers. because what happens is that if they're trying to attack the animals and they kill them, by the time that that's happened, the tracker doesn't show them as being moved, so it's good for keeping an eye on where the animals are. But what we're doing here is trying to find, well, maybe we shouldn't just be trying to find where the animals are, maybe we should be trying to find where these poachers are themselves, because those are the bits that are the biggest threat. So Daniel, I think we're at a point now where we've got millions of images here. We're never going to get through them all. We need to find a better way. We need to find a better way of checking all these 16 million images.
Yeah, I agree. I think, there's so many pictures. I think, we do need it. Oh, Craig, we've got another message coming from Bokamozo. Sorry to kind of... I'm going to put him on.
15 minutes until the poachers attack. Hurry!
Yeah, we don't really have much time. In fact, I'd go so far to say we maybe don't even have enough time. We need to stop these poachers before it's too late. So we need to find a way to use technology to help us with our problem. Like, computers are much faster than humans at doing some tasks. What if we could ask or teach a computer to look at the images for us? Maybe it could be doing all of this hard work to save us having to do it.
Yeah, so we're going to teach the computer how to recognise pictures that have humans in them. So to do that, we have to show the computer examples of photos with humans in them, and we also have to show them examples of photos without humans in them. So what you're doing is you're basically training it. You're telling it what is in the photo, and it's learning from your decisions. It's really easy for someone like us, Daniel, to look at a photo and determine if it's got a picture of a human in it or it's not. We're used to seeing these sort of things. And what we're doing is we're training it. So this is what's called supervised machine learning, because the way that you are watching over the machine and training it as well. So you're going to follow the instructions on your screen, and you're going to teach your computer what a human looks like, so it can do all the hard work for us and we can stop the poachers. So let's get going.
Yeah, just follow the instructions on the screen and train these computer systems. Now, while you're doing that, I'm going to tell you a bit about today's live lesson. So it's part of a project called Data Education in Schools. And the Data Education in Schools project is part of the Edinburgh and South East Scotland City Region Deal Skills Programme, and that's funded by the Scottish Government. Now, you can use data science skills to work in loads of different areas. So maybe that's healthcare or agriculture, finance, tourism, the public sector, or even something a bit more creative too. Now, data skills are important across all areas of science as well. So maybe if you want to work in physics or chemistry, biology, computer science, having data skills are really, really useful. They're really sought after in these areas. And if you've got the skills to understand data and to use data to make good decisions, well, that gives you a really good advantage in many jobs across these sectors.
Yeah, there's lots of job opportunities in this area across Scotland. And according to Skills Development Scotland, there's over 3,000 data scientists employed in Scotland. And the average salary for a data scientist in Scotland is about £52,000 per year. So to give you an idea, that's about double the average of other jobs. So it's a well-paid area to work in too. So after today's activity, you should go to the Data Schools website. So it's dataschools.education. You can also find them on Twitter as well and join their newsletter. So that's a way that you can keep up to date with types of events like this that we're doing today, but other ways that you can learn about data science and learn about these skills in your classroom. So Daniel, how's our data dashboard looking here?
Yeah, so let's come back to these numbers at the bottom here. So I can see with this number down here, it says 1,877. That's how many images you have checked, and you've looked to see if they've got poachers on. And that number is going up and up and up. It's climbing all of the time as you keep doing more scrolling. And the number next to it...
So they're doing the swiping at this point,
You're doing the
Daniel.
swiping, yeah.
They're putting them into piles. This is how many we're categorising.
Yeah, and you're swiping. The more you put in the pile that says there is a human, and the more you put in the pile that says there isn't a human, that's going to increase the accuracy of our model. And we want this number to be as high as possible. So let's see how close we can get the score to 100%.
I mean, I was going to say, Daniel, about 90% is even good, but like we're above that already. So keep working through this. Look how many we've checked so far, over 2,000.
Yeah, we're 91% now. This is brilliant. I'm just seeing as well, Craig, like the Rhino safety level down there, it's dropped a bit. It's dropped slightly to 19%. I suppose that's because we think these poachers are getting closer and there's less time to go.
But hopefully, if we can train this machine learning model, Daniel, then what this should allow us to do is check all those 16 million photos, hopefully quicker than it would do for us to do it by hand or sort of manually here. So it's important that people keep working through these images. We've got over 3,000 categorized now here. So tell us a bit about this, Daniel. So what's this sort of thing called?
Yeah, so this is an example of image classification, and this is a real task that people in data science might do, and it's a way of teaching a computer to identify things. So Craig, you might have actually done a bit of image classification yourself already, and all of you watching probably have done too. Have you ever had to click on every box that has a traffic light whenever you try to log into a website, perhaps?
Yeah, or it's like, what does an American crosswalk look like? So they ask someone from Glasgow as if, oh yeah, I know what an American fire hydrant looks like. Yeah, so this is used by companies all the time. Companies might be asking you to click on pictures of fire hydrants or cars, to log in. But what you're doing here is you're actually helping train their computers. So Daniel, Google uses this same technique for their self-driving car project.
Yeah, they do. They use it with Waymo, which is they have electric taxis that are self-driving with no driver in them in America, and it's really smart because they can teach the computer how to spot things like fire hydrants or bikes, and those are really easy things for us to do as humans because we grow up around them, we see them all the time. But a computer system won't know what a bike looks like, or it won't know what traffic lights look like in different situations from different angles unless we teach it. So what Google's doing is they're getting us to do that really repetitive and that laborious work. Maybe you're finding that just now. Maybe you're starting to get a bit fatigued of getting them. Maybe it's getting more difficult to put them in the right pile. Well, this is just like that. We're training our computer system to spot people, and then we can look at the list of images that have people in them to see if we can find any potential poachers in there. Craig, I think we've got our model pretty accurate. I'm quite happy with almost 95%. I don't think many are going to slip through at that.
Are you happy to move on at this point? Do you want to give people another minute or so? What's our... I know you can see the other dashboard as well. How are we looking there?
Yeah, let's see. Well, it looks like all of you are trading or have trained your machine learning model. So well done.
Thanks,
and Bethany, Ailey, Kelly, Aaron, good job.
Brilliant, Daniel. So if we've got over 5,000 images checked and our model accuracy is about 95%, just below 95% of the model, at the moment, that's looking pretty accurate to me. Why don't we test it and see if it's up to scratch?
Yeah, I think that's a brilliant idea. So I think we should test our model now that we've got it trained. Let's see if it works. So what we'd like you to do is follow the instructions on your screen to test your model. And this means the machine learning model is going to do the work for you. It's going to check all of these photos for poachers. And fingers crossed it's going to be quicker at checking them than it was when you were doing it manually. I can see a lot of you are running these tests just now. I think we'll maybe let you take 30 seconds to run the test. And do you know what? I think I might run one too and see how it works on my data. Craig, it's so fast.
Is it?
It's really
What's
fast.
happening?
Yeah, so do you know what? It's with my model that I've just done, it's 14,000 times faster than it was doing it manually, by hand.
14,000 times faster than doing it by hand.
Yeah.
That's much better. That's much better. So that should mean that we should be able to work through these images much quicker. 14,000 times faster, that's so much quicker than looking through it manually. Maybe what we could do, Daniel, is look at bringing the models together. Like, can we form a more, potentially stronger model that could be even more accurate? So this is a technique in data science. It's called ensemble learning.
Yeah, it is. And the reason why we're thinking of doing that as well, you've just created dozens of really accurate models. You've just trained loads of models. It'd be a shame if we didn't bring them together, because that could make something that's stronger. And the way this works, the way that ensemble learning works, is we ask all of your models the same question. We give them all the same picture and we see what's the majority answer. So if we've got 50 of your models and we've got about that, and we give them all the same photo, and 48 of them say there is a human in there, well, we can be really confident that there is a human in there if almost all of your models are agreeing and saying that it's found a human. So that's what we're going to do next.
So to combine your models, we need you to upload them to us. So make sure you're following the instructions on the screen and you're uploading your models. What's happening right now? Daniel, who's taking part?
So I can see Kai has already uploaded the machine learning model. All of us just tested their model and they're looking at the graph of how effective it is. I think they're about to upload it next. I can see that A at Ross Hall, you've uploaded your model. Karis at Ross Hall, your model's been uploaded. Craig, there's loads of models being uploaded.
That's great. Let's keep it on this screen and allow people a few more moments to keep updating their models. This is great. I can see people are still uploading it, Daniel. This is going to be super useful and we should be able to combine them shortly as well.
Yeah, all of these models are going to really help us create something that's going to be more accurate. So thanks, Bailey, Ewan, Scott, Daisy. Your models have now been uploaded. I've got them here. I can see them on my screen, and we're almost ready to combine them all together.
Okay, I'm just checking how people are getting on, Daniel. So just give me a. So I can see that Mr. Henderson's class have been taking part as well today. They've been sharing the work that they've been doing. So hello to Arbroath Academy.
Hello also to Trinity High School. I can see that you're joining us today. And Shawlands Academy in Glasgow. We've got Aberdeen Grammar School as well. Dunoon Grammar School. Aboyne Academy. Mint Law Academy. Hopefully you can see your avatars and your progress appearing on this screen too.
Daniel, we should do this every day. We should just get a bunch of school pupils to just do all our work for us. How does that sound? And we could just oversee it just like this from our operations centre.
I think that's a great idea.
This is serious. Like, obviously, we're needing to look after these rhinos. Daniel, I think we've had quite a few models uploaded to us now. Are we just about ready to combine them?
Yeah, I'm happy to combine the models, and the good thing is as well with the way that it is programmed is even if you're about to upload your model, we can add it in afterwards. So don't worry if yours is still uploading, because I know depending on the internet connection in your school it might take a bit longer. Don't worry about that, it will still go into the final model.
We can just merge it in.
Yeah, exactly.
Just merge it in.
Yeah, we'll do a merge. So, but let's combine the ones that are already uploaded. I think I've got about 30 or 40. Here we go.
Amazing. This is it's worked, Daniel. It's combined all the models.
It's great. I can see that. Yeah, it's successful. No error messages. Yeah, this is
First
good
time
news.
as well. When was the last time we ran a program that worked first time like that? So we've combined all our models. Now let's use this powerful model you've created to check the photos for us. Now remember, we've got over 16 million photos that we need to check, and there's new images being added every second. We said that if we did this manually, it would take about 2 years for us to go through all the photos. So let's use this combined model now, Daniel. Let's see if we can do it any quicker than 2 years.
Yeah, let's process these photos.
Daniel, that's really fast.
Yeah, wow.
Oh, that's so much quicker. Look how fast it's going.
We're halfway there.
Already? This is so much quicker. We're nearly there. They're all checked. They're all checked.
Yeah, you did it. So that was so much faster. So because you trained your models, we were able to easily check all of the photos for poachers. So we've now got a list of predictions where the poachers might have been seen, and we've sent them over to Bokamozo. In fact, they were automatically sent to Bokamozo.
Daniel, there's another message coming in from Bokamozo. It looks serious.
It looks serious. Right, I better put them on.
5 minutes until the poachers attack. Quick, tell me where to send the chopper.
Ooh, you're right, Craig. He does sound worried.
Not got long to go.
No, yeah, we're nearly there, but we do need to be really quick with this next section.
Okay, so you need to follow the instructions and prepare the data for visualization. So once you've done that, you'll be able to help us try and work out what group of rhinos that we think is most likely to be under attack. Now, Daniel, at the moment, we need to work quickly because the poachers are on their way. Now, what's happened here, Daniel, is we've checked all the photos, and we now have a sort of list of where we think these poachers might be. But it's just a list of locations. It would be quite hard to kind of look through all those locations and try and work out, well, what does this mean?
Yeah, exactly. So what we've got is we've got a list of all the photos that have humans in them, and Bokamozo's had a look and said these are the ones that look like they're poachers, and he's looked at, well, which one of these posts took the photo, and we know the location of the post, so we can see, okay, so we're spotted at this post, and then we're spotted at this post. But yeah, like Craig, you're saying, if we've just got them as a list of coordinates, that's really difficult to work out what direction they're going in and where they're coming from, whereas I think putting them on a map is going to make it so much easier to identify where they're going.
So a map is basically, sometimes we think of data visualization, Daniel, as things like bar charts or pie graphs or things like that. But is a map an example of visualizing data, or can it be used for that?
Yeah, absolutely. Maps are definitely a way of visualizing data. Maps have so much data on them. They've got sort of landmass, got geographic features, they might have altitude, they have buildings, roads, other pieces of sort of infrastructure we've built. Yeah, there's loads of information contained in maps, and all that information is data. And we can add even more data on top of that data to make it more meaningful, and that's what we're doing. We're combining a good map, but we're also adding on our layer of coordinates where we think we've spotted the poachers.
And then it's up to you as the data scientist to be looking at that visualization, analysing it and understanding it and helping us answer that question, which is, where are the poachers? What group of rhinos do we think are under attack? So what we've seen here, Daniel, so Aaron from Ross Hall Academy has identified the poachers on the map. David from Ross Hall thinks he's identified the poachers on the map as well.
Yep, A, I and L, who are also from Ross Hall Academy. Yeah, you've also identified the poachers on the map. Kelly, you've identified the poachers on the map too. And do you know what, Craig? I'm looking at these answers, and they're all kind of lining up. They're all for the same crash of rhinos. They're all for the same group.
Okay. How confident are you?
I'm pretty confident, but I think it would be good to have a few more opinions come in. So if you could map and then let us know, then that would be great, because then the more confident we can be, the better. Because, you know, what happens next is Bokamozo sends a helicopter because it's really far away from where he is, but that's what he does. So yeah, we need to be really confident it's the right place.
Well, definitely, Daniel, even if it's just purely for the, you know, climate potential of sending a helicopter, let's make sure we're confident we know where we're sending it so we don't waste fuel.
I see a few more of you have identified the poachers on the map. A, M, Reem, all at Ross Hall Academy. You've worked out where the poachers are. And again, there's a lot of agreement here.
Okay. What can you see, Daniel? I mean, are you confident enough based on what we've been getting from our data scientists here?
Yeah, I'm going to call it, right. I think we know the name of the group of rhinos under attack, and we think it right. You're listening? It's Umatatu. Umatatu. Can you
Umatatu.
Could you let
right,
Bokamozo
hang on,
know?
I'll send that to Bokamozo now. I hope we're right. Let's see what he says.
Okay, let's see.
You did it! I've sent the helicopter. The park rangers are on their way.
Oh, well done. You figured out
Yes.
the group of rhinos that was in danger is Umatatu. And we've sent a helicopter out to deal with the poachers, so the rhinos are safe.
Oh, that's brilliant. Well done, everyone. Congratulations for working through this activity. You had to do a lot of work to try and defend those rhinos. Let's think about what you did. So you downloaded a data set of 16 million images taken from posts right across the park. And to do that, you used a terminal to give the computer commands. Then you experimented with processing that data by hand. So essentially, you were looking through all those photos individually to try and spot the poachers. But we realized it would take too long to do that for 16 million images manually. So instead then, you trained a machine learning model to find humans in the photographs. And we ran that model against the entire data set of 16 million images. And it was so much quicker. What would have taken us 2 million years? What would have taken us over 2 years to do by hand? We were able to do, Daniel, in about 20 or 30 seconds because of that machine learning model. And finally, you created a data visualization that helped us try and understand that data. It was no use in having that list of the output from the model without understanding it or knowing what it meant. So you used a map to find where the poachers are in the park, and then we sent out a chopper to deal with them. Well done.
Well done. So thank you for being part of our data science team. We couldn't have done it without your help. And your hard work training the models and using your data science skills has kept the rhinos safe for another day. Now, there is one more task that we need you to do, and it is an important one. We need you to answer a few questions about today's event and tell us what you thought.
So click continue if you haven't already and answer the questions that come up on your screen. You will get your report card back at the end. It would be brilliant if, you know, a teacher or an adult took a picture of your report card. They can share it with us at data_schools at Ada Scott and hashtag #DataSkillsLive.
We're also on YouTube today, Craig, and I think it'd be a wasted opportunity if I didn't say like the video and subscribe to the channel, because if you subscribe to the channel, you'll get notified for all of our future activities.
Now, speaking of future activities, Daniel, there's an exciting one that we've got coming up in just a couple of weeks' time, and it's about data science, isn't it? But it also ties into something else that's going to be happening near us.
It does. So it's during COP26, and it's another live session all about how you can use data science to reduce your school's carbon footprint. So if you'd like to know more about that, or register, the link is in the description for this video, and you'll find it on our website as well.
That's going to be really exciting, Daniel. I know that we're still working on it just now, and we've been learning so much about sort of maths behind it, but a bit of physics as well. But also, if you're interested in climate change and ways that we can convince people of things, or different things that we could be doing, and working out the costs, the benefits, what would it make a difference if you had a solar panel at your school? Would it make a difference if every school in Scotland had a solar panel at their school? I guess these are things that we can do next month, Daniel, when we plug in the numbers.
Absolutely. And in the meantime, if you do want to try another data science activity that's available for you to play right now, you don't have to wait. Well, I'd recommend Code Your Own Data Selfie, and you'll find that on our website, which is cyberskillslive.com.
This has been brilliant, Daniel. This has been a fantastic morning, and I'm so glad we've been able to defend the rhinos. I hope everyone has been enjoying the Ada Scotland Festival as well and taking part in other activities. And hopefully it's got you thinking about, studying, whether it's in computing science or in a related area like data science as well.
But for now, I'd like to say thank you again for joining us today and enjoy the rest of the festival. But it's goodbye from Bokamozo. He tells me he sends his goodbyes, but there's a lot of noise on the helicopter. It's very loud. But it's bye from Craig.
Bye-bye.
And it's bye from me as well. See you next time.
Apex dropping bombs.